Newton's three laws are one way to describe the dynamics of a system. We've also learned that energy and conservation of energy can also be used for that purpose. But there is a third mathematically equivalent system, and that is impulse and momentum. In this particular experiment, we are going to consider the result of a collision between two objects, one that is moving with a certain velocity and one at rest. Now, momentum, unlike energy, is a vector, and therefore direction makes a difference. The title of this particular experiment is Collisions in Two Dimensions. In this experiment, you will discover that momentum is conserved in two perpendicular directions. The momentum of the ball approaching the one at rest is going to equal the sum of the momenta in that direction after the collision. And then at right angles to that, the momentum of one ball is going to equal the momentum of the other ball, but again, in opposite directions. The materials for this experiment are a ramp set up near the edge of a table, a string and small weight to form a plumb bob, some tape, a meter stick or equivalent, and a protractor. Here is a video showing a marble rolling down a ramp and colliding with a second one near the edge of a table. Note the horizontal lines shown in the picture above represent the edge of the table, and the blue dot is the collision point. Attach a plumb bob to the edge of the table at the collision point and mark its location on the floor with a piece of tape. First, let the marble roll off the table without the second marble in place. Mark the point on the floor where the marble lands with a piece of tape. Next, put the second marble in place. Release the marble from the same point on the ramp as the first time, and mark both points on the floor where the two marbles land. Measure the displacements of each marble with a meter stick, and the angles with a protractor. Multiply each distance by the mass of the marbles to get the magnitude of each momentum vector, and create a scale drawing like the one shown above. Use algebraic analysis to compare the initial and final momentum in the x direction, which should be 0, and in the y direction. The sum of the final y momentum should equal the initial momentum vector. Repeat the experiment using a heavier marble as a striking marble. The displacements will no longer be proportional to the velocity vectors, or the momentum vectors. You will need to multiply by the different masses of the two marbles in order to get the correct lengths of those vectors.